Hello all, this is Sandeep Kumar and I welcome you back to my YouTube channel Math with Sandeep. We are in the chapter of continuity in calculus, differential calculus, and in today's video let us discuss more problems on problems of discontinuity. Already in the previous video we have discussed some basic questions on problems of discontinuity, and in today's video let us discuss around 7 problems on the problems of discontinuity, which are very important for both mains and advanced. Okay, so do listen the video carefully and do practice these problems to excel the concept on discontinuity. Okay, now so we will solve the problems. We will check whether the function is continuous or not at the given points, and in case they are discontinuous we will also discuss what type of discontinuity is present at those points. Okay, now so 3 questions are written and 4 more problems are there. Let us start solving the questions. In case if you are new to the videos and the channel, don't forget to subscribe it, but obviously you can do that once completing the video. So if you find this video useful, obviously you can subscribe it, and let us start solving this. This is the first question. They told us to find the points of discontinuity of this function f of x, which is step x plus step of minus x at x is equal to 1. At which point is also important. This is step function, greatest integer function. Okay, now see at x is equal to 1, let me find the left hand limit and also right hand limit, and obviously the value of the function also. First, left hand limit at x is equal to 1. So limit x approaches 1 from left side. What is this function? Step x plus step of minus x. So when the function contains steps, let us convert it into h. We can write x is equal to 1 minus h, where h is approaching 0, particularly 0 plus. Okay, now h is positive. Keep this in mind. If that is the case, so what happens here? Limit h approaches 0, step of, instead of x we are writing 1 minus h, plus step of minus x means minus of 1 minus h, correct? Minus of 1 minus h. Okay, so which is equal to limit h approaches 0, step of 1 minus h, and inside the other step we will get h minus 1. Now if you substitute h as 0.000 something, what value will you get here? 1 minus h is what? 1 minus 0.000 something, which is 0.999 something. Okay, now and this particular value, if I substitute h as 0.00 something, 0.000 something minus 1 is minus 0.99 something. And dear students, we all know that step of 0.999 and so on is 0, and step of minus 0.999 and so on is minus 1. So therefore the left hand limit, what is it? The left hand limit is equal to 0 minus 1, which is minus 1. So the left hand limit is equal to minus 1. Similarly, let us also find what is right hand limit, RHL. So it is a limit x approaches 0 plus. X approaches 0 plus step x plus step of minus x. X approaches 0 plus means x is equal to 0 plus h, where h approaches 0. Correct? So the function becomes what? Limit h approaches 0. Instead of x we will write 0 plus h, which means h, plus step of minus h. A small correction, it is not 0 plus, it is 1 plus. At x is equal to 1 we are finding the right hand limit, right? X approaches 1 plus, therefore x is equal to 1 plus h. Okay, now where h approaches 0, so instead of x we are writing 1 plus h, and here also instead of minus x what are we writing? Minus of 1 plus h. There is a possibility of making mistake in this particular step. Please be careful. There is a possibility of making mistake in this particular step. You should not do that kind of mistakes. This is minus 1 minus h, which means minus 1 minus 0.000 something. So this is minus 1.000 something. Okay, now and this is 1 plus 0.000 something. So 1.00 something. And step of 1.000 something is 1. And step of minus 1.000 something is minus 2. Please observe. These are our basics. So 1 minus 2 is minus 1. Even RHL is also equal to minus 1. The left hand limit is minus 1. the right hand limit is also minus 1. That does not mean that we will conclude that the function is continuous. Please wait. For continuity, LHL should be equal to RHL, and at the same time they also must be equal to value of the function. Now what is the value of the function at x is equal to 1? F of 1. Let us try to find what is the value of the function, which is step 1 plus step of minus 1. Step 1 is 1 and step of minus 1 is also minus 1. 1 minus 1 is 0. Dear students, LHL is equal to RHL but not equal to value of the function. Of course, the value of the function is also is 0, a finite number, it exists. So if that is the case, we have already discussed it in the types of discontinuity. What type of discontinuity does the function has? Limit exists but it is not equal to value of the function. It is what type of discontinuity? The function is discontinuous at f of x is equal to at x is equal to 1, and it is what? Isolated point discontinuity. Isolated point discontinuity. So whenever left hand limit is equal to right hand limit but not equal to value of the function, where value of the function is a finite number, here finite number. Okay, if that is the case, we have isolated point discontinuity at x is equal to 1. So that is the solution of first question. Okay, now in case if you do not have clarity about what types of discontinuities are there, do check the video of types of discontinuity in the playlist of continuity. Okay, now you can find it. Anyhow, let us go for the next question. Question number 2. Second question. If f of x is equal to this when x is less than pi by 2 and this when x is greater than or equal to pi by 2. So where this is fractional part function and this is greatest integer function, step function. If that is the case, they told us to find the type of discontinuity at x is equal to pi by 2. If it exists. If the discontinuity exists, then what is the type of discontinuity? Okay, now so let us start solving it, and let us first find the left hand limit at x is equal to pi by 2. Observe. So left hand limit at x is equal to pi by 2 is limit x approaches pi by 2 minus f of x. And what is f of x here? X is approaching pi by 2 from the left side means x is less than pi by 2 only, right? If x is less than pi by 2, we are going to take f of x as cos inverse of fractional part of cot x. Okay, dear students, this is equal to, see, observe one thing, cos inverse of fractional part of cot of, what is x here? Pi by 2 minus. Please observe one thing, dear students, cot 90 is 0. But when input is just lesser than 90, that means 89 degrees or something, 89.999 and so on, then the value of cot, please observe this angle is in first quadrant, cot must be positive. Cot 90 is 0, but cot of 89.99 and so on is what? 0.000 and so on. Is it clear? So cos inverse of, and fractional part of 0.000 and so on is 0.000 and so on. But we will not generally write 0.000 and so on. We will write 0 plus. Okay, now, and even 0 plus is also not needed. Cos inverse of 0. And what is the answer? It is equal to pi by 2. Cos inverse of 0 is pi by 2. In case if you are confused with this, you can write x as pi by 2 minus h. And then you can start solving the same problem by taking x as what? Pi by 2 minus h and writing h approaches 0. You will get the answer just like that. Okay, now, but I hope you understood this. You will get 0.000 and so on, but it is positive. So cos inverse of 0 plus. Instead of 0 plus, I will write cos inverse of 0 and we will get pi by 2. If you want exact answer, cos inverse of 0 plus will be pi by 2 minus. Okay, but anyhow, it's fine. We will take the answer as pi by 2. The left hand limit is pi by 2. Next, let us see what is right hand limit. Okay, remember that LHL is equal to pi by 2. Now let us go with RHL. When x is approaching pi by 2 from the right side, it means x is more than pi by 2. X is greater than pi by 2. Since x is greater than pi by 2, instead of f of x, I will write pi into step x minus 1. Dear students, this is easy. X is pi by 2 plus means it is equal to pi into step of pi by 2 is approximately 1.57. It is 1.57 plus. So instead of x I have written pi by 2 plus pi by 2 value is approximately 1.557. Yes, of course. Minus 1. Anyhow, step of 1.57 something is how much? 1 minus 1. So pi into 1 minus 1 is pi minus 1. Dear students, observe that left hand limit is pi by 2 but right hand limit is pi minus 1. So obviously left hand limit is not equal to right hand limit. So it is non-removable discontinuity. But obviously left hand limit is a finite number and right hand limit is also a finite number. None of them are approaching infinity. Therefore it is what type of discontinuity? It is jump type discontinuity, or else we can also say that it is finite type discontinuity. You can write jump type or finite type. Okay, now both are same itself. So the function has the finite type discontinuity at x is equal to pi by 2. Sometimes in the same question what they will ask us means they'll ask us to find the value of the jump. They'll ask us to find the value of the jump. Value of jump is equal to modulus of LHL minus RHL. So you can calculate it. So what is it? Modulus of LHL is pi by 2 minus RHL is pi minus 1. But here larger number is, I'll take larger minus smaller. Obviously pi minus 1 is larger, minus, I'll write RHL minus LHL because inside the modulus it can be either way. You can write LHL minus RHL or RHL minus LHL. I'm writing modulus of pi minus 1 minus pi by 2. Obviously this is a positive number because this is 3.14. This is 1.57, and if you calculate you will get a positive number. So mod is not needed. So the answer is what? The value of the jump is pi minus 1 minus pi by 2. Modulus is not needed. Okay, now so this is about the second question. Let us go with next question. Third question, a little caution must be added while solving this particular question. So they have given function f of x. If input is greater than 0, you can take this function, and if input is less than 0, you can take this function. But they did not say what is f of x when input x is equal to 0. They did not mention. Okay, fine. And they told us to find the value of f of 0 if the function is continuous at x is equal to 0. See, do not misunderstand. Don't think that they had said that the function is continuous at x is equal to 0. They did not say. They told us to find the value of f of 0 if f of x is continuous. If f of x is continuous, find the value of f of 0. If not, we will write that f of x is not defined, or f of 0 does not exist. Okay, now fine. Let us start solving the question. First, let us find LHL, and after that RHL, and then we will start. So we will conclude what is f of 0. First LHL. Okay, first let us find RHL itself. RHL is limit x approaches 0 plus. Okay, now f of x. And what is f of x? When input is more than 0, f of x is log cos x base e divided by 4th root of 1 plus x square minus 1. In case if you have practiced limits chapter well, obviously you will know how to solve this question. But if you are not getting the idea, it's very important to practice the problems on 0 by 0 form. Particularly the problems on rational functions. I mean, if the denominator, if it contains root over something, these kind of functions, okay, now root f of x minus root g of x, these kind of functions, and at the same time limits on logarithmic functions. Okay, so obviously if you have practiced those problems well, you'll get the idea. Step 1 is when I substitute x as 0, I'm getting 0 by 0 form. Okay, it is 0 by 0 form. And do you remember that limit x approaches a, log of 1 plus f of x divided by f of x will be equal to 1 if f of x is approaching 0. Do you remember this? In logarithms we have discussed already. You can go and check once logarithmic limits in the playlist of limits. Okay, when x is approaching a, if f of x is approaching 0, then log of 1 plus f of x by f of x is 1. Okay, remember this. So I want 1 here, 1 plus. For that reason, what will I do is limit x approaches 0 plus log of, I'll write cos x as 1 plus cos x minus 1. Is it clear? I just added 1 and I subtracted 1. Okay, and next this is in the form of what? Log of 1 plus f of x. And please observe one thing, when x is approaching 0 from the right side, okay, or we will do one thing. First let me convert the variable x into variable h, and after that we will start solving this process. So x is approaching 0 plus means what, dear students? It means x is equal to 0 plus h, where h is approaching 0. So the function becomes limit h approaches 0 log cos of, instead of x we can write h, divided by 4th root of 1 plus h square minus 1. Okay, 4th root of this one. Okay, now let us work out this. Let me convert this as 1 plus f of x, or 1 plus f of x. Okay, so limit h approaches 0 log of 1 plus, since I added 1, I will also subtract 1. Now observe one thing, dear students. If this is f of x or f of h, okay na, when h is approaching 0, what is the value of this function? When h is approaching 0, cos 0 is 1 minus 1. You are getting 0 only na? This is taking 0. So the numerator is in the form of log of 1 plus f of h. So I want f of h in the denominator. What is that f of h? Cos h minus 1. So I divided it with cos h minus 1. Let me also multiply it with cos h minus 1. Okay now, and in the denominator we have 4th root of 1 plus h square minus 1. Let me multiply this with its conjugate. I mean its rationalizing factor. The rationalizing factor of 4th root of f of x minus 1 is 4th root of f of x plus 1. That is the rationalizing factor of it. So let me multiply the denominator and numerator with its rationalizing factor. So what is it? In the denominator we had 4th root of 1 plus h square minus 1. I will multiply with it with the 4th root of 1 plus h square plus 1. If I multiply it in the denominator, I should also multiply it in the numerator. 4th root of 1 plus h square plus 1. Next, let me do this step here itself. A minus b into a plus b is a square minus b square. Okay na? So that means what? You will get 4th root of 1 plus h square whole square minus 1 square. If I multiply these two using a minus b into a plus b, I will get a square minus b square. So the denominator becomes what, dear students? 4th root means power 1 by 4. Power 1 by 4 into power 2. So you will get square root. This becomes square root of 1 plus h square minus 1. Okay now, so the denominator after multiplication, I am writing it directly here. After multiplying these two, we get square root of, what do we get here, students? Square root of 1 plus h square minus 1. Okay now, fine. Next, after this, let us see what to do. Fine. Now, dear students, log of 1 plus f of h divided by f of h is 1 according to logarithmic limits. So limit h approaches 0. So this is going to become 1. And cos h minus 1 as it is. Cos h minus 1 as it is. In this function, you can substitute h value as 0. And when I substitute h value as 0, I'll get 4th root of 1 plus 1. 4th root of 1 is 1. 1 plus 1 is 2. So I got this in the numerator. And in denominator, we have root over 1 plus h square minus 1. Once again, let us rationalize the denominator by multiplying it with its conjugate, which is root of 1 plus h square plus 1. So I multiplied with it in the denominator and also in the numerator. We are very close to the solution. Okay, so what happens to the denominator now? So cos h minus 1 is there. Now let me take minus common. You will understand why. Minus, I'll write 2 here, into 1 minus cos h into, here we can substitute h value as 0. Okay now, we can substitute h value as 0. So 1 plus 0 is 1. Root 1 is 1. 1 plus 1 is 2. Okay, divided by, again you can use a minus b into a plus b. You will get a square. What is root 1 plus h square whole square? You will get 1 plus h square only. No? So a square minus b square. So what is it, dear students? 1 and minus 1 will get cancelled. So we are very close to our answer. Minus 2 into 2 is minus 4 into, in trigonometric limits we have learned that limit h approaches 0, 1 minus cos h divided by h square is 1 by 2. We have discussed it and we have used it many times in trigonometric limits. So the answer is minus 2. What answer? The right hand limit. The right hand limit is equal to minus 2. And there is another method of solving all this. You can use L'Hospital's rule because it is in 0 by 0 form, you can use L'Hospital's rule also. Okay, use L'Hospital's rule and find the answer. But I am not depending much on L'Hospital's rule because I want to teach what is the method to find the limits. Many students will get the answer by L'Hospital's rule, but that does not mean that I'll get the answer always using L'Hospital's rule. Sometimes finding derivatives will be difficult. For that reason, I'm sticking most of the times to the process instead of using L'Hospital's rule. But to save time, particularly while solving questions in mains and advanced, you can choose using L'Hospital's rule in numerator and denominator. You will get the answer. Okay, now. So I got left hand limit as -2. Now let us go for right hand limit. Now let us find left hand limit. So LHL is equal to limit x approaches 0 minus f of x. X approaches 0 minus means x is less than 0. So f of x is this. E power sine 4x minus 1 by log of 1 plus tan 2x. We can use exponential limits and logarithmic limits to answer this question. Initially, when x is approaching 0 minus, the numerator is taking 0 form and the denominator is also taking 0 form. And let us see how to use logarithmic limits. But before that, x is approaching 0 minus means I'll write x is equal to 0 minus h, where h is approaching 0. So the function becomes what? Limit h approaches 0 e power sine of 4 into, instead of x, I am taking minus h. Instead of x, I will take minus h. Na? So 4 into minus h is minus 4h, which means minus sine 4h. Actually, you will get sine of minus 4h. I can take minus outside. Minus 1 whole divided by log of 1 plus tan of 2 into minus h. X is minus h na. 2 into minus h, which is minus 2h, and here also minus comes out. I'm just writing it in the same step. You will get tan of minus 2h and minus comes out. Okay, now dear students, this is already in the form of e power f of x minus 1. The numerator is in the form of e power f of x minus 1 or e power f of h minus 1. And when h is approaching 0, this f of h is also approaching 0. Because if I substitute h as 0, I'll get 0 here. Sine of 0, 0. Since f of h is approaching 0, I can use this form. What is it? Limit f of x approaching 0, e power f of x minus 1 by f of x is 1. So for that reason, what I'll do in the numerator, I'll write as limit h approaches 0, e power minus sine 4h minus 1 divided by, the f of h is minus sine 4h. So divide it with minus sine 4h and also multiply with minus sine 4h whole divided by. Now this is already in the form of this log of 1 plus f of x by f of x, where f of x is approaching 0, then this value is 1. So it is in the form of 1 plus log of 1 plus f of x, sorry, f of h. So what is it? The denominator is in the form of 1 plus log of 1 plus 1 plus minus of tan 2h. So here f of h is minus tan 2h. So divide it with minus tan 2h and also multiply with minus tan 2h. Okay, now dear students, now this is going to be 1 because of this formula. This is also going to be 1 because of this formula. So 1 by 1 not needed. Minus and minus gets cancelled. Okay, now, and one more step, we will get the answer. So limit h approaches 0, sine 4h divided by tan 2h. So here I'll divide with h and I'll multiply with h, or let us do one thing, divide the numerator and denominator with h. Divide the numerator with h and also denominator with h. Using the trigonometric limits, this value will become 4 and this value will become 2. You must know all these basics in trigonometric limits. So the answer is 2. Observe one thing, dear students. We have got LHL value. And already, what is it? LHL is 2 and already we have found RHL, which is minus 2. The left hand limit is not equal to right hand limit. So we have a discontinuity. It is non-removable type discontinuity, and particularly it is finite type discontinuity. So therefore, dear students, since left hand limit is not equal to right hand limit, it is not possible to find the value of f of 0. In case if both are equal, okay, in case if both are equal, this is 2 and that is 2, I can say that f of 0 is also 2 and the function is continuous at x is equal to 0. But here left hand limit is not equal to right hand limit, right? So for that reason the function is not continuous at x is equal to 0. So we cannot say what is f of 0 value. F of 0 value is does not exist. F of 0 does not exist. We cannot define it to make the function continuous. So this is third question. Let us go for next question. So they told us to discuss the type of discontinuity of f of x equal to step of cos x minus step of sin x at x is equal to pi by 2 if it exists. If the discontinuity exists, let us see what is the type of discontinuity. Okay now. So first let us find LHL. So LHL is equal to limit x approaches pi by 2 minus step of cos x minus step of sin x. So it's always advisable to convert it in terms of h. So x is equal to pi by 2 minus h. Okay, and we can substitute where h is approaching 0. Substitute the same thing here. Limit h approaches 0. Step of cos of x is pi by 2 minus h. So pi by 2 minus h minus step of sin of, again x is pi by 2 minus h. So pi by 2 minus h. So which is equal to limit h approaches 0. This is going to be step of sin h. Cos of 90 minus h is sin h minus step of sin of 90 minus h is cos h. Now if you substitute h as 0, please observe one thing carefully. H is not exactly 0. H is 0.0000 something. So don't directly substitute h value as 0. We have to be careful at that particular point. So it is sin of h is 0 plus minus cos of, again h is 0 plus 0.0000 something. If you directly substitute h value as 0, you might get wrong answer. Okay, so that is where we have to be careful. And sin of 0 plus means 0.0000 something. Sin 0 is 0, but sin of 0 plus is 0 plus 0.0000 something. Okay na? Step of 0 plus minus, here cos 0 is 1, but cos of 0 point something is 0.999 and so on. Okay, if it is exactly cos 0, we could have written 1 here, but it is not exactly 0, it is 0.000 something. So the answer is 0.999 something. Think about it. So step of 0 point something is 0, and here step of 0.99 something is also 0. The left hand limit is 0. In case what happens if you directly substitute h as 0? This is okay, but here you will write cos 0, you will write 1 here, and step of 1 you will write 1, and you will get 0 minus 1 as minus 1. That is the mistake what students will do. Once again, what I am saying is, if you do not write 0 plus, if you write only 0, cos 0 is 1, and step of 1 you will write 1, and 0 minus 1 you will write minus 1 as answer, which is a wrong answer. We should be careful while playing with greatest integer functions, which means the step functions. So it is cos of 0 plus, and this is the value whose step is 0, and the final answer is 0. Okay na? So next, anyhow we got left hand limit as 0. Let us see what is right hand limit. I'll use the same solution to find the right hand limit. Remember, we have got left hand limit as 0. Okay na? So limit x approaches 0 plus same function, and x approaches pi by 2 plus means x is equal to pi by 2 plus h, where h is approaching 0, and instead of x we will write pi by 2 plus h, and here also instead of x we will write pi by 2 plus h, and cos of 90 plus h is minus sin h, and sin of 90 plus h is cos h itself. Next, dear students, this is minus sin of 0 plus, of course h is approaching 0, which is 0 plus only. Okay na? When h is approaching 0, it is taking positive value only. Okay, minus sin of 0 plus, and then this is cos of 0 plus. There is no change here. Here minus 0 plus, please observe one thing. Minus 0 plus, what is it? Minus 0 plus means minus 0.000 something, and step of minus 0.00 something is minus 1. Here there is no change. We will get what? Cos of 0 plus, so 0.99 so on, and its step is 0, And minus 1 minus 0 is how much, dear students? Minus 1. The right hand limit is minus 1. The left hand limit is 0. The right hand limit is minus 1. LHL is not equal to RHL. The function has a discontinuity at x is equal to pi by 2. And what type of discontinuity again? It is the same, the jump type discontinuity. Jump type is also called as a finite type discontinuity. The function has finite type discontinuity at x is equal to pi by 2. And sometimes they will also ask us to find the value of jump. The value of jump is modulus of LHL minus RHL. LHL minus RHL. So you will get a modulus of 1, which is nothing but 1. The value of jump is 1. Okay now. So the function has finite type discontinuity at x is equal to pi by 2 and the value of the jump is 1. So let us discuss one more problem. Here is our fifth question, and obviously you can try it, dear students. Try it, okay now. You can find LHL or you can find RHL and check what type of discontinuity you are getting in this particular question at x is equal to 1, and let me know what type of discontinuity has been raised in this problem in the comment section. Okay, so that's it on the problems of discontinuity. If needed in future, we will upload more problems on the types of discontinuity, and I hope you have understood the solutions of these problems and it is really helpful to you. So in case if it is helpful, don't forget to subscribe to the channel. If you are new, do like the video and share it with your friends. Let the channel grow. So in the upcoming videos, let us discuss about the continuity of the functions which are in the form of f of x plus g of x, or f of x minus g of x, or f of x into g of x, or f of x divided by g of x. So we will discuss about the functions which are in these forms. We will discuss about the continuity of these types of functions. Very important. Okay now, so let us discuss it in next video, and after that we will discuss about continuity of the functions which are in the form of step of f of x, continuities of the functions which are in the form of fractional part of f of x, and also the functions which are in the form of signum of f of x, functions whose limits are at infinity. We will discuss all about the continuity of those functions in the upcoming videos, and after that we will start with the chapter of differentiability. So we will see you all in next video. This is Sandeep Kumar. Take care.